Today we'll take some points on this particular topic called carbohydrates, which comes under a part of the biomolecules. Some examples of these carbohydrates like glucose and glyceraldehyde. If you observe their formulas, molecular formula of the glucose is C6H12O6. Glyceraldehyde has a formula C3H6O3, which can be summed up like this: CnH2O(N), which gives a misleading idea that all the carbons in this compound are attached through the H2O molecules. So therefore, they named as a carbohydrate. Hydrate means water attached molecules. So they thought initially all these molecules will have the carbons and attachment with the H2O, which is proved later wrong and redefined as the definition of the carbohydrates. Modern definition is they are polyhydroxy optically active carbonyl compounds. So there are 3 points we are defining. Polyhydroxy means a number of OH groups should be there, n number of OHs. Optically active means the lowest the understanding of this level understanding is a carbon containing the 4 different groups. Such a carbon we identify as a chiral carbon. If A, B, C, D groups are there, such a carbon we can call it as a chiral carbon. That optical activity comes around about this particular presence of this carbon. A carbonyl compound means it can be a aldehyde function or ketone. Aldehydes means one side hydrogen you can have. You can also alkyl or a hydrogen or any aromatic group. Or it can be a ketone. Ketone will not have a hydrogen, either alkyl or aromatic, or alkyl or aromatic. These are the ketones. So obviously here there is no aromatic system, so all aliphatic carbonyl compounds are there. So one such example is the lowest possible compound is an aldehyde containing the second carbon OH and third carbon also OH. The remaining will be fulfilled with the hydrogens. So there is one chiral carbon. Polyhydroxy has come now here. 2 OHs. 2 OHs, minimum is 2 OHs. Actually 2 cannot be poly, but still as a limitation we have here 2 is taken as a lowest for the polyhydroxy type, and there is an aldehyde function. With this formula you have another compound also like this. A carbonyl compound is there and 2 hydroxy is also there, but here we are missing the chiral carbon. So therefore, as per the definition, this won't be the carbohydrate. It is nothing but the 1,3-dihydroxypropanone, which is no more a carbohydrate. But this is a 2,3-dihydroxypropanaldehyde is called glyceraldehyde, as we have seen already. So let us have different examples and taking the classification of the carbohydrates. In the carbohydrates classification is the one of the important topic. Let us see the classification of the carbohydrates. The modern classification shows they are classified based on hydrolysis. The compound which on hydrolysis will not give any further breakages or hydrolyzes into pieces is called monosaccharide. That is the carbohydrates, also called sometimes referred as saccharides or saccharides. These are first base is called monosaccharides. Monosaccharide means which on hydrolysis with acidic catalyzed hydrolysis, no more further hydrolysis. No further means this is the smallest saccharide. If you can hydrolyze into two pieces, they are called disaccharides. Disaccharides means on hydrolysis you are getting the two monosaccharides. Similarly, you can also go for the trisaccharides and tetrasaccharides and so on, but in some books are giving, we are getting another section called oligosaccharides. Oligosaccharides means on hydrolysis you are getting 3 to up to 10 monosaccharides. When you are getting that type of these saccharides are called oligosaccharides. On hydrolysis, if many you are getting, that is called polysaccharides. Polysaccharides means huge number of, that means at least minimum more than 10 and number of monosaccharides if they are coming. Such a saccharide is called polysaccharide. So, monosaccharide means no further hydrolysis. So, for example, under this class we have glucose, fructose, ribose and so on. These are the main examples. Under disaccharides we have cellobiose, maltose, sucrose, raffinose is an example for the oligosaccharide. Polysaccharides we have starch is a best example, and cellulose is also one of the polysaccharide. The examples based on the examples we are getting the question. So, you may collect some more examples for each variety and you can go through it. The monosaccharides are further classified. They are further classified based on the number of carbons. How many carbons are there? Based on that, the classification goes like into trioses, tetroses, pentoses and hexoses. That is how many carbons are there. Based on that, triose. Triose is a glyceraldehyde example. Glyceraldehyde is the tetrose, erythrose and thriose. Erythrose and thriose is the examples for the tetroses. For pentoses, ribose, which is a constituent of the DNA and the RNA. RNA contains polyribonucleic acid is the DNA RNA. And second carbon, if OH is missing, it is called 2-deoxyribonucleic acid is a DNA. Both contain this 5-membered ring, pentose. Under the hexose, we have seen glucose and the fructose. Glucose and fructose are the examples for this. Again, this hexoses can be classified into the two varieties based on the functional group. What type of functional group we have? Aldoses and the ketoses. Aldoses and ketoses. In fact, glucose is an example for the aldose and the ketoses, fructose is the example. Like that, each member, pentoses, triose, tetrose also can be classified. So, glucose is an aldose, glucose is a hexose, glucose is also a monosaccharide. Glucose ultimately is a carbohydrate or it is a saccharide. But because it is not further hydrolyzed, we said it is monosaccharide. Because it contains 6 carbons, we said it is a hexose. And the glucose contains a aldehyde function, therefore it is called aldose. So, based on this, the first based on the hydrolysis concept. Second one, second step in fact based on the number of carbon atoms in the carbohydrate. The third point we have taken here, what type of carbonyl function is there? Is it aldehyde or a ketone? Based on that we have taken into this type, isn't it?